y-axis is here. I'm sorry, the x-axis is here, y equals 0. The line x equals 1, somewhere along in there,
Okay, next
and x equals 4. Okay?
question.
Yes.
With 1 over is greater than x, is that something like what we see in infinite area?
Right, yeah. By the way, what's actually cooler than that is that if I go this way, the area is infinite, but if I go this way, the area is finite, and it's actually trapped. This one is not, though.
Yeah. Wait, okay.
Area, like if I were to say, okay, from here that way or here that way, this area would be boundless, this area would be bounded. I know, right?
That makes
Perfect sense. Perfect sense. Alright, so there is y equals 1 over the root of x equals 1, x equals 4. Ooh, and now we're going around this line right here, x equals -3. Okay. Again, I always like to draw it in and put the arrow with the loop to say this is what, they don't care about that on the AP, but for your sake, to let you know which axis you're going around, it's kind of cool, kind of neat. So, alright, a few things to point out before we really get started. First, if I were going around x-axis, this would be the easiest thing in the world, disk method, done. If I were going around y-axis, okay, I can still use shell. You can use washer on this because there's a gap here. The problem is if you change it to y's, which you can actually do, it's not that hard to do, you'd have two zones. One going up this high with this line on top and this line on bottom, and a second one with the curve on top and this line on bottom. So if you were thinking disk or washer in this case, you would be forced to break it up into two zones.
Not bad.
If you go with shell, however, you've always got the height is uniform, one function on top, one function on the bottom, and it never changes positions. So let's start out by thinking shell, which is going to be 2 pi r h. This example, the h is easy. The h is our function value.
Yeah, it's the function. And then
The r is the one that's a little irritating. And these are going to be massive rings, because it's got a long way to go.
I don't know how I feel about that.
You don't have to feel anything, you just have to
just go,
do it.
it's being fucking on next. X equals -3, so it has to go around.
That's fine. Okay, so I'll give you this.
Yeah.
The height is going to be 1 over square root of x. That's our h. Okay, so the height, that's easy. What's the radius?
X plus 3.
Very good. Here's why it's not x. If you tell me that the radius is x, then you're telling me the radius is only this far. That's as far as x is. It's not just x, it's x and then some. In this case, x plus 3. Or more importantly, right side minus left side. X minus -3.
Yeah.
Okay? If you're thinking formulas and how to do it every single time, it's always subtraction. The distance between 2 points is always subtraction. So my radius for this one will be x plus 3. dx. Starting point and stopping point.
That's a good question.
Starting point and stopping point?
I need an interval.
Oh, 1 to 4.
Very good.
I don't know why it would change.
I don't either. But think about this, y'all. For the first, when you plug in 1, that doesn't mean you have a radius of 1.
That just means that's where you start.
that's where your first radius is calculated. Your radius at 1 would actually be 4, which makes sense. And your radius at 4 would be 7, which also makes sense, okay? So the x's themselves are going from 1 to 4. That is not necessarily what the radius is going to correspond to. All right, let's rock and roll. 2 pi. How would I do this one? Okay, I would probably distribute, because it's not gonna be that bad. You have a product rule now, the way it's written, that's hideous. Okay, x, to do some scratch work, this is x to the first over x to the 1/2, which is gonna be x to the 1/2. We're just subtracting the powers there. And then this one is going to be 3x to the negative 1/2. 3 times that. Did a little rewriting there so we could actually take an antiderivative. All right, 2 pi. Antiderivative of x to the 1/2. We got x to the 3/2.
2/3.
2/3 of that. It's an ugly 3/2, I apologize. For this one, we're gonna raise it 1 power and get x to the 1/2, then divide by that and get 6. Going from 1 to 4. Both of those numbers, by the way, are absolutely gorgeous inside those roots.
Yeah, it does.
2 pi, okay, so for the first one, we're gonna have, okay, square root of 4 is 2, 2 cubed is 8. 8 times 2/3 is 16/3. Square root of 4 is 2, so 12. When we stick in 1, we get 2/3 plus 6. Okay, alright. 2 pi. Alright. 12 minus 6 is 6. 16/3 minus 2/3 is 14/3. Come on, get it together. Alright, we got 2 pi, what is this? 18/3
18/3?
for 6.
Yeah.
18/3 plus 14/3 is 32/3.
Yeah.
32/3. For a grand total of 64 pi over 3, or whatever the decimal equivalent of that is. And if this were a calculator problem, I would be done here. Type it in, equals decimal, whatever that is. I do kind of like these on the non-calculator because they're not going to give them to you. Almost every single free response question with area and volume is a calculator one. I mean, the last, I think I told you, the last 15 years, maybe one or two, one I think hasn't been a calculator. All right, ladies and gentlemen,
It's 10 rotations of
shell method.
it's 10 rotations of unit circle.
It's,
It's, what would it be? It would be,
well, if you divide that, 63 would give you 21-ish. 21-ish pi is 10 and a half
10
rotation.
and a half, and then
A
get
little bit short, yeah. So you're somewhere in the
5.
third quadrant-ish, give or take. If you were doing trig values. Yeah. All right, how does shell method feel? Cool. Again, I have a second day set aside Monday. I don't really know that we need the Monday lesson for that. I do not, however, want, I'll leave it up to y'all. You wanna go ahead and knock out the quizzes Monday, or do you wanna have some time to study Monday? We can start quizzes on Monday. It's up
I'll
to you.
let you ready, because I won't be ready.
All right, so we'll make it Monday as a
Because I
little
know if I
bit
come in Monday, I won't be ready for it.
Q&A
Also-
time.
We have work keys again,
Oh, yeah,
Monday.
you might call work keys.
so you don't, I don't know when we're coming in, because
Yeah.
it's the rest of the
Alright.
time.
We're gonna go ahead and cut it here. Good job. Okay,
You want
there's all the
next?
examples. Yeah, and then we'll talk for a second about what's happening next week. Thank you, Amber.
Alright, let me, my mom, I keep telling her black binder on my desk. He's like, oh, is it the red one? I'm like, no, it's not the red one.